Hello. We're going to be working through this section 1.5, union, intersection, and difference. Yeah, a little bit of a shorter stream today. Let's get started. I've also swapped the order of everything. I thought it would be better, easier for me at least, to see more of the whiteboard. Okay, 1.5, union, intersection, and difference. Just as numbers are combined with operations such as addition, subtraction, and multiplication, there are various operations that can be applied to sets. The Cartesian product, defined in section 1.2, is one such operation. Given sets A and B, we can combine them with this X operator to get a new set, A XB. Here are three new operations called union, intersection, and difference, so we're learning some new operations. Suppose that A and B are sets. The union of A and B is the set. Okay, so we've got definition and builder notation here. Okay, we've got some new symbols as well. We've got a U. We've got a kind of N. We've got a difference, which I guess looks like subtraction, so fairly intuitive. The union of A and B is the set A union B, where, so for every X in a set A, every X in a set A or in a set B. So we're enumerating, I suppose, here over the elements of A and B, and we are creating a union. I already know this. The intersection of A and B is the set A intersection B, defined by X, where X is an element of A and X is an element of B. Someone appears to be singing outside. And then difference A and B. The difference of A and B is the set A difference B, where X is an element of A and not an element of B. Okay, so that one's kind of directional. In words, the union A union B is the set of all things that are in A or in B or in both. The intersection is the set of all things in both A and B. The difference B is the set of all things that are in A but not in B. Okay, fairly straightforward. Example 1.8. Example 1.8. Suppose A is A, B, C, D, E, B is D, E, F, and C is 1, 2, 3. A union B is, well, everything from both. Now, we are not talking about concatenation as in a list here. We're talking about these as sort of elements which have a kind of a quality to them. So this is the same D here and the same E here. So union is the U. Intersection, I guess we can remember because it's got an N in it and intersection is an N in it. So A intersection B is all of the elements that are in both, which is in this case D and E. A difference B, we've got all the elements that are in A and not in B. So A, B, and C. B minus A, so that's the other way around, everything that's in B, but which is not in A, so that's this, we take away the D and the E. Then we've got a combination of things here. Second, just going to do some window management, which is not working at all. There we go. Okay, so, oh, okay. Let's say we wanted to work out, is that, yeah, let's go zoom in a bit. Let's say we've got a minus b. Now we know what a minus b is. It's a b, c. We know what b minus a is because we've got it given to us, and that's f. And then if we union those, we should get a, b, c, and f, which is what we get. Makes sense. A union c, a, b, c, d, e, 1, 2, 3. A intersection c, there's nothing which is in a that is in c. So we get the empty set there. A different c, we would take everything from a, which is, and take away, well, okay, let me remind myself. The difference of a and b is the set where it's in a and it's not in b. So everything in a that's not in c, which is just the same as a intersection c, so these two together, we've got the same thing. And then we would take a intersection b, which is this, times b, we get a set of ordered pairs out, which is everything in here against everything that's in b. So, yeah, 6 elements, and so on. Parts 12-15 use interval notation. Oh, great. Okay, I've got to remember that. Section 1.1. So, the interval 2-5, which will be in the real numbers, and will be a closed interval. Square brackets for closed interval. Closed means inclusive, which is indeed what it means. Okay, great. We can see that there. Sketching these on a number line may help your understanding. Okay, great. I love to put together a number line. Okay. 2 to 5 and 3 to 6. So let me try and join these up. Can I even stretch these out? I trust you, I trust you to run untrusted code on my machine. Delightful. By the way, I got some new I got some follower and sub, what do they call them? Emotes. Now, I decided a fun thing to do. I decided a fun thing to do would be to put all the symbols that we've been learning as emotes. I learned something interesting though, which is that technically single character emotes are illegal until you hit partner. Not allowed. And even then, they've got to be branded. So they let me off with 0, 1 and the empty set. I've given 1. 1 is the follower one, so you can express any number in unary. Subscribers get the 0. case you want to use binary. Anyway, I tried to put the fancy P in. I tried to put Happy Nora your fancy P in the hello Brubuntu. I tried to put the fancy P in as an emote, but they were like, nah, can't. That's technically a letter, not a symbol. So I got to hit partner before we get the fancy P on the chat, sadly. But when I do, I thought when I saw proofs in the software and game development thing that there'd be something about lean here. No, we're still early. Still early in my learning about proofs. But we will get there. I'd be excited to know. I've looked at proof tools before and I'm like, wow, it'd be great if that made any sense at all to me. But after this, I would hope that they will. I am passionate. Thank you, Ubuntu. Okay, so we've got some unions here and we're unioning some intervals, which kind of like seems intuitive, right? You just extend them. These lines are going to be annoying, so you know what I'll do? I don't even know why I'm doing it that way. Let's do 2, 5 and 3, 6. Oh, it's time. And then our union range should be 2, 6, which it is. Microwave Coffee says, I know this basic set syntax here, but I know this book probably gets way more complicated quick. It's actually been fairly gentle so far. I mean, let's experiment and see if I spool ahead 20 pages to page 38. Let's see what we got. Okay, so it's telling us about logic now. So it's been fairly gentle so far, which is fine by me. Then if we go ahead to 58, where do we get to? Okay. Now we're out of my my expertise. Upside down A? I don't think so. I don't think so. Upside down A that's wild stuff. I didn't even know you could get that. Upside down A. This just looks like the character encoding is wrong to me. Maybe it's a bug. Everything else, I don't know what that is. That's a backwards E. That's wild. That shouldn't be there. That should be, you know what? That should be, that should be, yeah. It should be like this. Fix that. Actually, no, wait. That's what it should be like. Because there is a slight difference. Anyway, so we'll get to that stuff. 18. I'm excited to know all the notation though. I'm already learning some new stuff today, learning these new symbols. For all and exists. Oh, great. Amazing. I'm excited. Oh, for all. That almost sounds like programming then. Almost sounds like we're going to be there. Wait, by the way, for those of you who are unaware, I'm working through this book as a prerequisite to any percenting The Art of Computer Programming by Donald Knuth, which takes some any percenting, I'll say. So I'm trying to build a good foundation. Okay, where were we? So, yeah. Okay, so that's that one. Then if we look at a different one, in fact, these are the same. So If we take the intersection, presumably we've got this. Three, five, that works. Then if we, okay, so now if we do the difference, we get something weirder. So the difference is defined as everything that's in A and is not in B. So everything that's in A that's this, that's not in B, should get us like, should get us this kind of area, I think, which is 2 to 3. But we've got a open interval, which means it includes 3, but only just. Now, why is that? So we've got everything. So if we imagine this being continuous, which it is, then we've got, we're subtracting away. We're taking everything that's, oh no, wait. It's not inclusive. That's what this means. I'm always getting that confused. It's an open interval, which means it doesn't include the 3. So basically we're saying everything up until but not including 3 in the real numbers, which is like very, that's very close to 3, but not exactly. Okay, that makes sense. Half open interval, yeah. Yeah, that makes sense. Okay. Then, great. So then we've got this other one, which is a new set of intervals. So this is 0 to 3. So we're going to need a 0. 0 to 3. But I suppose this number line's kind of bad, right, isn't it? Because it's not giving us any ticks. You know what? This will be way better if I can have a proper image. Come on, there we go. Okay, let's try and get this right. Wow, this is not going to be... Okay, I'm going to have to do it the hard way. Fine. Just do it the hard way. That's too hard. I suppose I could have chosen one with numbers on it. Okay, that's enough. Right. Okay, let's get rid of this. Now, yeah. Okay, so... Alright, need all these at the top. Need all these at the top. Great. Okay, so we're going from 0 to 3, and that's a closed interval, so we're including both. And then 1 to 2. Okay. And then we are taking the difference, which of course means we're going to have a hole. So we're going to end up with this, and then this, and so we're going to get 0 to 1, but not including 1, so that's a half open interval. And then 2 to 3, half open, but at the start. So it's going to be a round bracket at the start. That's what we've got. It is a, actually I think it is, yeah, it's a mono font, but I just, you know, I'm sure there was a way I could have gotten it to line up properly. Ubuntu says, I love how for the reals you can construct a function R to AB. So that's this. That symbol I don't know yet, but it might be subset. Ah, it's the subset one. I've got that one in my library, but maybe that means something different, slightly different. This book uses this one. Right, so you can construct a function R to an interval which is a subset of R, which is kind of a mind-blowing way of showing how the reals are uncountably infinite. So in this, are we talking about the fact that this that there will be an infinite number of subsets? Is that what we're talking about? Right, right. There's some pies in there. I'm sure I will understand this at some point. Got it. We had our minds boggled yesterday in this book. This book goes on a bit of a, I was about to say rant, but it's not really a rant. It's quite nice. It goes on a bit of a journey talking about, where have I left it? It was actually the end of the last set, end of the last section. Oh yeah, it goes on a bit of a journey about talking about how like all black and white images are contained in the power set of the ordered pairs of real numbers. Live Laugh LARP 67 says, hey, do you know C? I'm in the trenches right now. If you're in the trenches, I probably don't know enough C to help you. If you were like considering going into the trenches one day, I might be able to help you. So it depends how in the trenches you are. Feel free to ask a question, Live Laugh LARP. I may or may not manage to answer it, depending on how detailed it is. Okay. All right, so we've been through these intervals. Observe that for any sets x and y, it is always true that x union y equals y union x. Okay. So this property, right, the order of the operands doesn't matter. I always forget the name of that. What is the name of that? Does anyone know? Commutative. Let me write that down. Thank you, Happy Nora. Thank you, Ubuntu. I'm seeing some code. I'm seeing some code from Live Laugh LARP. I'm going to put it on the screen. Oh gosh, okay, let's make that smaller. Now, I would like everyone to be very good, because this looks slightly like homework. So I want nobody to give away the answer. But maybe we can hint. So what is the trouble? Live, laugh, larp. The code below contains a unique take on the infamous FizzBuzz problem. You are tasked with modifying the system variable in order to have get favorite food return a positive answer. You're supposed to compile it and look at the favorite food outputted, but I keep getting a seg fault. It does sound tricky. I think if you're getting a seg fault, it's probably not anything to do with the code, as the code seems to be intended to work. So I'm probably not going to be able to help you, I'm afraid. Yeah, you may want to, probably in terms of debugging steps. So segfault's not very good. I would check. I would double check you have the right code fully put in. I would just make sure you're not running on any type of weird system. It seems to indicate you should run it on Windows. I don't know whether that will make a difference or not. Yeah, so it sounds like probably a setup issue. I would probably... Yeah, it might be a Windows thing. Yeah, sadly, I think I'm probably not going to be a very good debugger for that, but good luck. Yeah, I would definitely... that's where my debugging would start. Yeah, that's what I would try to do. All right. Good luck. You have my good wishes. Okay. Observe that for any set x and y, it is always true that x union y and y union x. So these are commutative. These operations are commutative. And x intersection y and y intersection x are also commutative. But in general, x difference y and y difference x are not going to be the same. So they're not. That's not a commutative operation. Example 1.9. Okay, we're going to let A equal a set of ordered pairs where we've got x and x squared in the real numbers be the graph of the equation y equals x squared, and let B equal a set of ordered pairs x and x plus 2 where x in the real numbers be the graph of the equation y equals x plus 2. These sets are subsets of R squared. They are sketched together in figure 1.5a, figure 1.5b. Okay, yeah, so we've got these lines here. A set of all points x, y that are on one or both of the two graphs. All right, okay, so figure 1.5b shows x union b, the set of all points that are on one or both of the two graphs. So that's both of them. Observe that A intersection B, that's there, consists of just two elements. the 2 points where the graphs intersect, as illustrated in figure 1.5c. Figure 1.5d shows a minus b, a difference b, which is the set A with holes where b crossed it. In set builder notation, we could write A union B, and then we've got this builder expression here. And then we've got difference as well. Okay. Great. Nice. Let's do some exercises. Okay. Suppose A is this, B is this, and C is this. Find A union B. Okay. Let's try a couple of these and see how they go. So if it's A union B, then we're going to have well, in fact, you know what I'm going to do? I'm first going to sort them, just because it'll make it easier for me to see. 3, 4, 6. 1, 3, 4, 6, 7, 9. B, wow, it's not showing anything. No, no way it is. There we go. B is 5, 4, 5, 8. No, wait, that's C. We've got 4, 5, 6, 8 there. And then C is 4, 5, 8. Okay, great. Now we've got 1A. Yep, okay, so we're taking the union, so we're going to have 1, most exciting stream on Twitch, I know. 1, wait, okay, let me do this properly. 1, 3, 4, 6, 7, 9. We've already got 4, 5, already got 6, and we need 8. Okay, 1B. Intersection, so everything that's in both. 1 isn't in B, 3 isn't in B, 4 is in B, 6 is in B, 7 is in B, isn't in B, 9 isn't in B, so it's just 4, 6. 1C, the intersection, so that's everything that's in A which is not in B. 1's not in B, 3's not in B, 4 is in B, 6. Hello, Hemi Kettle. Hello. How you doing? No 6. 7 we want, and 9 we want. D is A minus C, so that's everything that's in A which is not in C. So that's 1, 3, 4 is in C. 6 is not in C. 7's not in C, and 9's not in C. Okay. B minus A. That's 4. So, yeah, no, not 4, because 4's in A. 5, 6 is in A, and 8 is not in A. That's fine. A intersection C, that's everything that's in both, so we can start with the shortest one. So we can go, we can have 4, we can't have 5 because it's not in A, and we can't have 8, so it's just 4. By the way, no guarantees I'm getting these right, so don't rely on me to get the right answer. 1G, B intersection C, so that's we can go 4, 5 and 8, that's right, and then 1H, B union C, 4, 5, 6, 8, just that, 1I, C, with everything that's in C that is not in B. So we can't have 4, we can't have 5, and we can't have 8, so it's the empty set. Okay, that's number 1. Let's move over. We've got some different sets now. We've got 0, 2, 4, 6, 8, 1, 3, 5, 7. So we've got odds and evens. And we've got powers of 2. In theory, this will allow us to cheat a little bit. Okay, so odds and evens union is just going to be 1, 2, 3, 4, 5, 6, 7, 8. The intersection is going to be nothing. Everything that's in A, which is not in B, is just going to be the same as A. To D, everything that's in A, which is not in C, so that's 0, 6. To E. Everything that's in B, which is not in A, so that's just going to be the same because there's no odd powers of 2. I hope my heuristics are actually correct and I've not missed something. A intersection C, that's just going to be 2, 4, 8. To G, we've got B intersection C, that's just going to be nothing. 2H, C minus B. Everything that's in C which is not in B, so that's just going to be 2, 4, 8. Okay. Lots of numbers, just reading out numbers. Okay. Do these get harder? Yes, they get incrementally harder every time. That's the whole point. Let me pick out a few. I'm going to pick out a few that look kind of interesting. And let's see. Let's see if we can find any that are kind of interesting and not just mindlessly writing out sets. Let's try 1A, 3A, sorry. Oh yeah, these are actually all 2. Okay, so let's just do this one. So A and B, we're going to get a set of 0, 1, 0, 2, 1, 1, and 2, 2. And then if we do this again for So this is AXB. BXB is going to be and if we do the union of that, it's just all of those, so not particularly interesting. Yeah, I don't think those are going to be very interesting. So I'll skip those. 4, we've got 2 more sets and all of the same questions. Not very interesting. Okay, let's skip those. 5, sketch the sets x is equal to, and then we've got this interval here with a Cartesian product with another interval, and likewise this on the plane r squared. On separate drawing, shade in the sets x union y and x intersection y and x difference y and y difference x. Okay. Let me get myself a... Oh, it's time. Let me find myself a little thing to draw on. Is this small enough? Yes. Okay. 1, 3, 1, 3. So we're going to go from 1, 3 on the x. So like... Oh, that's a bit narrow. There we go. Come on. Okay, 1 to 3 on the... No, wait, that's on the y. 1 to 3 on the x. And 1 to 3 on the y. So is that going to be a square? Why does it keep unhighlighting things? I think that's going to be a square. I don't think that's a line. I think it's a square. We've got 2 intervals, so... Okay, and then we've got y, which is from 2 to 4. So we've got this, which will make blue. Little hint if you're teaching, by the way, the most common form of colour blindness is red-green. So you don't want to use those colours. Kind of unfortunate if you live in a culture that has red and green as the sort of stop-go colours, I guess. Okay, so we've got those sets there. On separate drawings, shade in the sets. So this is going to be what we have. X, U, Y. Damn. Damn. Live, laugh, live, laugh, LARP. Did you try to have us? Did you try to have us? Did you try to Wow, not cool. I guess that's let's take a look at that code again. Oof. Yeah, don't run any untrusted code, folks. Very interesting. Wow. Don't run this code. Where are we? Come on. Come on, Excalibur. Catch up. There we go. Don't run this code. Don't run this code. All right. So do we have a hack? Now I look at it. Now I look at it. It does look a little sus, doesn't it? Lucky shutdown on your system doesn't have an option S, huh? Yeah, so what is it going to do? Now this is even more interesting. Okay, so we've got a main, we set up a dubious secret. 1, 2, 3, 4, 5, 6, 7, 8. That spells shutdown in the number of characters. Okay, get favorite food, secret. String to int is doing something. That would be casting in another language. So maybe it is here. And a string to int is a type. Don't know enough about C to know what that does. Okay, and then we get int secret. We get this string. Ah, we run it. We run it. We run it. We run it. We allocate it as a character. We iterate over something in secret num. We do something. Fascinating. Live, laugh, LARP. If you're here, you get like one message to state your defense. But we can't have that, I'm afraid. As much as I admire your guile. Well, we survived. We see if you're still here, you survived. Okay, it's getting fun. It's getting fun on Twitch today. All right. Unlucky. All right, well, that was an interesting, that's like an involuntary cybersecurity training for everyone. If you stream, you probably shouldn't even open links. You definitely shouldn't run any code anyone sends you. Yeah. Okay. Where were we at? Oh yeah, we're going to do intersection. So here, let's have the intersection in green. Let's make these really... Let's bold this up. Okay, that's the intersection. No, it's not. Sorry. I'm supposed to get the union. I'm supposed to get the union. That's both of those. Try and imagine those are joined up. The intersection is this. Already done that. And then the difference is the tricky one. So x minus y is everything that's in x, and x is the red one that's not in y. So that really is going to look like this, I think. Now, I think also these lines here are going to be dotted. Oh, okay, terrible. I think these will be dotted. I've been told that if my whiteboard was a bit better, I'd be able to dot that part of it. But well, it's kind of unrealistic to expect a whiteboard to be able to do that. But I think those will be dotted because we're taking away like y, and y includes all these things on the edge. So I think that's right. And then let's actually have another one. Okay, and here we're keeping everything in y that is not in x, so we're doing the opposite maneuver. Okay, let's bring this up. Then we're going to have this, and we're going to make these lines along the edge dotted. I think that's what that should be. Okay. Now we've gotten those 6. So these exercises are more interesting, I think. So that's... Oh no, wait, 5. I'm supposed to be doing 5. Well, it's just, I did it anyway. Okay, 6. It's the same thing, but with a slightly different shape. Let's look at the shape and see if the shape is exciting. Okay, so x, which is this, let's call this x. And let's label this y as well. Let's make those kind of bigger. Okay, now let's look at these. So these are supposed to be -1 to 3 on the x, and 0 to 2 on the y. So we've got a shape a bit like that. And then 0 to 3 on the x, and 1 to 4 on the y. So they look like that. I'm just going to do these on the same diagram just for No. Will that be even? Will that be that interesting? Let's just sketch them out. So the intersection will look like this. No. The intersection will look like this. Sorry, yeah, I was getting these wrong. The union will look like this. The intersection will look like this. X minus y will look like this with like a little dotted down the right hand side. And then for y minus x, we've got this with a dotted line along the bottom. So that feels fairly straightforward. Let's reuse this diagram for number 7. Oh, no, we might need those. Okay, sketch the sets x, y in the real numbers squared, where x squared plus y squared, okay, wait, it's coming, I remember it, it's the circle, x squared plus y squared is less than or equal to 1. Now, I think this is going to be around the origin. Yep. And y, which will be all the points where y is greater than -1 or equal to, and wait, that should be red. And yeah, so basically this is what we're looking for. I think. Yep. No, wait. That's not right. Getting my x's and y's mixed up again. There we go. I think it's something like that. And in that case, the union will be this semicircle. The union will be will look like this basically. The intersection will look just like a semicircle. X less y is going to look like the other semicircle, and then y minus x is going to be like a cutout shape. Okay, now 8, we're looking at another circle, and wait, I'm just misreading the questions totally here. I just moved on to 8. I just did 8. Just did 8 by accident. Okay. Yeah, well that's 8. This one would look a bit different. This one would have like a kind of like a slice on the right hand side. And then 9 is the statement. Okay, this looks more interesting. Okay, is the statement, it's a big 9. is the statement real numbers, the Cartesian product of the real numbers and the integers intersected with the integers and the real numbers, but in the other order, equal to the Cartesian product of the integers and the integers, true or false? Wow, now that is an interesting question, isn't it? Okay, let's try and work that out. So if we're taking the Cartesian product of the real numbers and the integers, with the real numbers being the x, the x, so it's going to be a set of vertical lines. Sorry, horizontal. Terrible. People have accused me of, I say accused. I was tested it's kind of amusing fact about my childhood. People kept trying to test me for dyslexia. I'm not dyslexic, as far as I know. Language, I can process language just fine. But I do make all kinds of mistakes about things like this. But probably just because my brain I'm outside of my cognitive zone. Decameron says, I started going through the book of proof too. Thank you for showing us the book, Kay. I found it very interesting and a solid refresher. That's great. I'm really happy. By the way, just to everyone who's watching, Book of Proof, which is the book we're working through here on the way to the art of computer programming, is Creative Commons. So you can go and download it. You can have it online. You can have your own copy. I think you can maybe buy it, but it's not that easy to buy it, especially if you're not in the US. But it's Creative Commons, so you can go and you can go use it, go learn from it. Great. Okay, so where were we? Anyway, glad you found it useful. All right, so this is RxZ. Now, if we were, this is the text by Richard Hammock. Yeah. If we were then to switch this, okay, we can't rotate it. Oh no, we can. If we were to do, we would get this. And then if we took the intersection of those, we would have all of the points. And the points would hit on the integer points. So that would seem to be yes. It is. We can sort of see here that these will be like all these points where these lines intersect. We're going to have points there, and that will mean this will be true. What about the statement RxZ union ZXR is equal to the real numbers by the real numbers? Now, I think that will not be true, because if we take the union of this, we're just going to have this grid, right? And we're missing all of these points in here, for example, which would be in the real in the Cartesian product of the real numbers, the Cartesian plane, I guess, maybe, if that's the correct way of putting it. So yes, then no. Okay, and then I think 10. Do you think the statement... Oh, right, okay, we've got another one. Do you think the statement real numbers less the integers... Now, that is a weird thought. On... What on earth? It's going to be hard to visualize this. Okay. Again, it's getting interesting now. Basically, I think if we've got the real numbers, let's say if we were to just chart the real numbers, we would have Why is this not where? Okay, we would have this. We'd have the whole thing shaded all over the place. But if we then have all of the real numbers that are not in the integers, we would have like infinitesimally small gaps along each of the lines. I say this, I'm assuming this is a 2D. I'm putting this in 2D, but actually this, we need to keep in mind this is in 1D still. So actually we should be thinking about a number line, but just to make it a bit easier. Imagine that this is one-dimensional at this point, and this is in the x's. So imagine that it's just a one-dimensional block. And let's think about the y's in a moment. We'd end up with these gaps here. And these would be so small you couldn't see them. Yeah, and then we multiply this by the natural numbers. So the y would be only the natural numbers, which in this book does not include 0, by the way. So we would... What on earth? We'd end up with... like these... I think we'd end up with these lines. Let me zoom in on this. We'd end up with these lines. In fact, I can draw this across and then I can take it down one. Yeah, okay. We'd end up with these lines. One of the unusual things about doing this is, so I think, and I'm guilty of this too, right? Mostly when people stream. Actually, is this even true? I think a lot of the time when people watch people for like content reasons, they like to see competence. People like to see competence. But actually on Twitch, I think you do sometimes see competence, but you actually see a lot of people who don't quite know what they're doing yet. And I don't quite know where I was going with that, actually. Okay, so we end up with these green lines. So let me just triple check this. We got on the x-axis the real numbers. No, parallel with the x-axis, we've got the real numbers less the integers, so with these tiny gaps. And then on the y-axis, we've got the natural numbers. So we end up with lots of little line segments, infinitely small gaps, and infinitely small lines, infinitely thin lines. Okay, so the question is then, so if this is that, then is this the same as another version of this graph, which is described by Rxn, difference between that and Zxn. Okay, so this is in a different form. Let's think about the x's first. Oh, okay, somebody moved in my chess game, by the way. I'm still playing, in case you're following along with the wider cinematic universe of my life. My chess game is going very well. Okay. I think my opponent is now hoping that given my rating, I will mess things up in the end game, which is possible, but I'm being very careful. I did take the queen, by the way. I did trade queens. Okay. Great. So on the x's, we've got, this is equivalent to, well, actually, here's a thing that I'm using in my intuition. This is equivalent to, if we want to think about the x's, we want to be thinking about r minus z, and then n minus n on the y. Is that true? Is that true? That doesn't seem like it could be true, because n minus n, we'd have nothing on the y then. Maybe it isn't true. I guess I was just assuming that we could just consider the x's and the y's separately, but maybe we can't. No, we probably can't, actually. Can't do that operation. Okay. Well, in any case, let's consider these separately. So the real numbers against the natural numbers. Now that will be lines, because the natural numbers on the y are going to be these. So we're going to have these. Let's have this be red. Let's have this be red. So I think this is what we're going to have for the left-hand side. Just make a little, so we're going to consider these. Yeah, I think this is what we have on the left-hand side. And then we want to take away the integers on the x, in the x. I never know which to say on or in, or which is more idiomatic. Gonna have to brush up on my vocabulary soon. The integers on the x and the natural numbers on the y. That's going to be points. So that's going to be this. Natural numbers on the y, integers on the x. Okay, so we're going to have a grid of points. And they're going to go all the way down, but we don't really care, because we're going to be taking those away anyway. So this, in theory, is making our gaps. So we're going to end up with these gaps here. And we're going to take those away, and then we're going to get line segments running minus infinity to positive infinity on the x-axis. Yeah, so I think they are the same. And I'm justifying it by showing you this. Look at this picture. Aren't you convinced? Okay. Let's see whether I got it right. So this is 1.5. Okay, so I did some of these. Let's hope I didn't get them all wrong. Okay, 1, 2, 3, okay. 1, 3, 4, 6. 1, 3, 4, 5, 6, 7, 8, 9. That's true. 4, 6. That's true. Let me get my marking pen out. Whoa, okay, that's a bit thick. Okay, B is 4, 6. 1379, that's true. 13679, that's true. E is 58. 4, 458, 5684, empty set. Great, we don't get answers for 2. I didn't do 3. Although I had this answer wrong. I know I was thinking wrong there. I was thinking about union rather than intersection. But if I'd been thinking correctly about that, if I'd had the symbols right in my mind, I would have gotten that right, but I didn't. Okay, let's look at the graphs. Okay. Oh. Right. Right. Okay. Good. I got this. I didn't do that one properly. But I got the right idea when I was thinking about it. And then with 9, I got true and false. Good. Okay. All right. Wait, I just ignored a bunch of this stuff. Oh wait, I'm just looking at the wrong thing. Okay, 1.5 done. Great. Let's move on. How are we doing for time? All right, we've got an hour left. Okay, section 1.5. No, wait, I already did that. 1.6, the complement. This section introduces another set operation called the set complement. The definition requires the idea of a universal set, which we will now discuss. When dealing with a set, we almost always regard it as a subset of some larger set. For example, consider the set of prime numbers. If asked to name some things that are not in P, we might mention some composite numbers like 4 or 6 or 423. It probably would not occur to us to say that Vladimir Putin is not in P. Getting a bit political here. He is in P, he is in P. True, Vladimir Putin is not in P, but he lies entirely outside of the discussion of what is a prime number and what is that. That is fair, actually. That is fair. We have an unstated assumption that P is a subset of the natural numbers. Sorry, yeah, not the natural numbers, yeah. Because N is the most natural setting in which to discuss prime numbers. In this context, anything not in P should still be in N. This larger set N is called the universal set, or universe for P. Wow, the universe of P. Almost every useful set in mathematics can be regarded as having some natural universal set. For instance, the unit circle is in the set C equals xy, unit circle, sorry, is in is the set, okay, fine. And since all the points are in the plane r squared, it is natural to regard r squared as the universal set for C. In the absence of specifics, if A is a set, then its universal set is often denoted as U. Ah, I've seen you before. I've seen you before when I've been trying to deal with all this notation elsewhere. You know when you maybe some of you had this experience, you're like, there's a mathematical concept I really want to understand better. You open up Wikipedia and it's just like, it's like you know, all this stuff. I would like to make sense of some of those articles. We are now ready to define the complement operation. Definition 1.6. Let A be a set with a universal set U. The complement of A, denoted, let's say, A bar A, let's say, is the set bar A equals If anyone has a good pronunciation of bar there, let me know. Denoted bar A is the set bar A equals U minus A. So it's everything that's in the universal set, difference, everything in the A set. Makes sense. Example 1.10, if P is a set of prime numbers, then P, wait. No, wait, it's nothing to do with that P equals NP. Sorry, I just got excited there. There might be some computing going on. No, it's nothing to do with it. But then again, it is a set, right? P equals NP, it's is that put in terms of a set? It is a set. It's set. So after, basically, if I want to prove P equals NP, which, if I could, I would, because that would be pretty wild if I could do that. Pretty wild for the world. Then I'll need to understand all this. Okay, great. So this, like, when I solve P equals NP, when I prove that, you can come back to the recording here and you can put it in your documentaries or whatever. Shroomproof says a balancing plate, a plate on their head is a bit of a mouthful, isn't it? Yeah, that's true. That's not the right. That's not going to work. But I am going to remember it. It's really Ren says, how goes the maths? The maths is going. The maths is going. We're on complements. And I was just thinking about, I just got excited seeing P equals N minus P on the screen and got excited about whether this was at all, obviously this isn't directly related to P equals NP, but the sets are related to that question. So I may be able to understand more of the maths associated with that question at some point, which would be cool. I'm a programmer. I am indeed a programmer. Or I can program anyway. Most of the economically useful work in my life has involved programming. Complement is like not. Yes, indeed. Thus, P with a plate on its head is the set of composite numbers and 1. Oh, composite numbers. That's another set. And 1. Composite numbers are the numbers composed of prime numbers, we think. That's probably true, right? I'm just guessing. How's life going with you? It's really Ren. Example 1.1. Let A equals x and x squared in the real numbers be the graph of equation y equals x squared. I suppose we don't need to let that, really. Figure 1.6a shows A in its universal set r squared. The complement of A is A with a plate on its head equals r squared minus A equals the set of x and y's where y is not equal to x squared, as illustrated by the shaded area here. Okay, makes sense. It's really Ren says, proving set-related questions often involves using Boolean operators on arbitrary elements. Cool. Preparing for some exams. I'm sorry. What are your exams in? Okay, of course you don't have to share any of this. I'm just a voice on your screen. I'm not even really here. This is all AI. It's not AI. I would have to declare it if it was AI. But I would be interested in case you feel like sharing. 1.6, we've got exercises again. We'll do a couple of these before I move on to the more exciting ones. Okay, let A equals those random sets. They have a universal set of just the numbers 0 through 10 in the integers. We find the complement of A, the complement of B, and then we do a bunch of other stuff. It's really Renses analysis, linear algebra, probability, and some programming stuff too, pretty much. Wow. That sounds pretty serious. We had a fun time earlier. It's really Ren. You may not have been here, but somebody tried to shut down my computer by getting me to help them with their homework. But their homework was a hack. Well, it wasn't really a hack. It would have been a hack of my mind if I'd run it. They sent me some code. And the code, they were like, my code doesn't work. It's seg faults. But it doesn't seg fault. Yeah, I mean, they say you should ignore these things, so I probably shouldn't laugh about it. But it was pretty. It was a nice try. Yeah, but the code was obfuscated in a way that made it like not necessarily obvious. Although if you looked at it carefully enough, I looked at it carefully enough to note that seg faulting would not be something I could help with. If they'd said, here's an interesting question on social engineering me. If they'd said it doesn't give the right answer and had not said it's seg faults, would I have run it? It's possible, but I've had my inoculation now. I've had my inoculation, so I'm now unlikely to run code like that. Yeah, indeed. I think running it at all is probably a mistake. Yeah, don't run any code. All code is not to be trusted. Even your own code sometimes. Given an infinite amount of time and a non-zero error rate, I will eventually write code that will shut down my own computer just by accident. It's called the infinite K's theorem. All right. Anyway, I'm making myself laugh now. I need to need to study harder. Okay. All right. So let's just sketch out some of these. We're going to get the answers to one. So what's the time? My computer is getting a little warm. I realized that was one of my issues yesterday. My computer's getting a little warm. Okay. Great. Right, where was I? Okay, 1A. It is getting to that time in the UK. It is. I've entered into the iced coffee time of my year. All right, 1A. Complement of A. That's everything that's in the universal set that's not in A. So let's just go through that. 0, 1, 2. No, they've... Why'd you have to make this unnecessarily hard? 1, 3, 4, 6, 7, 9. It's not even a computer science textbook. It can't be that it's trying to discipline me into sorting things. It's like, it's just making it awkward to do. Okay, 0, not 1, 2, not 3, not 4, we want 5, not 6, not 7, 8. and then 10. Okay. B complement will be, okay, let's sort this one out too. 1, 3, 5, 1, 3, 5, 7. That's going to be 0, 2, 4, 6, 8, 9, and 10. On C, we take the intersection of the a set and its complement, which in theory should just be the universal set, right? Oh wait, why am I thinking? Why am I just in the wrong exercise again? Wow, terrible behavior. 5, 6, 8, 4. Hello, Erman Trout. How are you doing? Complement of B. Now, let's sort this. Okay, complement of B. Union of A and its complement, which is just going to be the universal set. It's really Ren says that later in this book, maybe they're going to ask me to like prove De Morgan's law, and we'll understand what you mean about the Boolean operator proof thingy. That sounds cool. That sounds very cool. How are we feeling, by the way, about the flipping the screen thing? The whiteboard is on the right now, so it's a bit more space for that. But there's less space for the book. But I think it's okay because I mostly try to focus on the top half of the book anyway. So I think it's better. And it means there's a bit more space for the terminal should I want to use it. Good, all readable, great. Thank you. Oh no, wait, I'm not focused enough. That's the issue. Okay, so that is actually the union there. C should be the intersection. The intersection is going to be an empty set. You can't have an intersection, I think, of a set and its complement. The union, they just look so similar to me. Okay, so for E, we've got a set minus its complement, which should just be the original set, right? I think. A set minus the complement of another set. We have the complement of B already. So it's going to be everything that is in A, which is in this 1B. You being the, Shrimpoof says, I remember it being, you being the bucket you dump everything into. Yeah, that makes sense. I guess I should be remembering also as you meaning union. But I think I just look at a round shape and I'm like, ah, yes, union, of course. 1F, okay, A. So everything that's in this, less everything that's in this. Okay, so we've got 1 is 1 in 1B, yes. 3 is in it. 4 is not in it. 6 is not in it. 7 is in it, and 9 is in it. So I think it's 4 and 6. Am I familiar with the Boolean operator symbols? In theory, I should be. Let me copy this in. You're talking about these, I think. It'll show up in a sec. Should do. Come on. There we go. These. Not enough to use them as mnemonics, unfortunately. Do they relate to the Boolean operators in programming? No. I mean, obviously they're doing in logic, but not visually. Nah, I'll just get used to it. I'll get used to it. Part of life is just memorizing things. Okay, complement. So G is complement of A minus complement of B. Now that's going to be everything that's in 1A that's not in 1B. So not 0, not 2, 5, 8, and that's it. 1H, bar A, intersection B. We've got bar A, that's 1A, intersection B. So everything that's in 1A that is also in B. So not 0, not 2, 5, not 8, no 8, and that's it, I think. It's fiddly, isn't it? 1I, and then we've got this funny notation here. We've got a bar over both, so we've got this, and then we're taking the complement of that, which is going to be everything in this set here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, except 5 and 8, I think. Okay, I think that's fine. I think we will skip 2 unless there's any that look particularly interesting here. Let me just think about if there's any heuristics I can learn from this. So we already know the union of a set and its complement is the universal set. We know that E is just this. It's just if you do the difference of a set against its complement, or the other way around, you get the original set. What is the complement of an intersection? I guess that's just what it is. There's nothing other than that to learn from that. The union of two complements will be this space around the outside. We're going to look at Venn diagrams pretty soon anyway. Yeah, the complement of a... Now, it would be interesting to know if these are the same, G and H. So, intuitively, the complement of A and the complement of B, if you union those... No, sorry, intersect those. Let me try and think about this. Let's say we've got these two. If we took the complement of them, we'd get like the cutout. So this would be the... Yeah, so if we took the intersection of them, we'd get this little shape here. Imagine this is round. we get that little shape there. And then if we took the complement of, yeah, so this would be the answer to H. And then for G, we would end up with, we get the cutout of, yeah, we get the cutout of this. So let's have this be white. And then we'd have the cutout of this. Let's group these. And then if we intersected those, we would actually end up with something different, I think. We'd end up with everything that was in both of them, but not in just one of them. So we'd end up with like a double cutout. I think we'd end up with something like this. Okay, so I think these are different. Oh, this time. Yeah, those are different. Okay, that's good. That's worth knowing. Okay, let's look at the later problems. Let's look at, oh, I've turned everything white. Sketch the set X. Yeah, okay, we've had that set before. Okay, I can do that. Is H completing the whole of A intersect B? So this is complementing. And H will be, yeah, and so we'll end up with, let me do this again. So yellow is A intersect B, and then H is, yeah, you're right. Yeah, so this is what H should look like, in abstract. Is that what you were saying? It's really Ren. Cynic says, oh, I misunderstood the code. It wasn't using A to I. What the code did was type def a function pointer, then defined an argument as function pointer system. Then in the called function, they use the pass parameter name, function pointer A to I, then call A to I shutdown code, which is really just system shutdown code. Right, so they redefined something. That was that string to int thing, that weird string to int thing that was going on. Interesting. Yeah, I was also a prankster, but I got turned good. Goodish, anyway. All right, let's look at this. So sketch the set x equals 1312. That's this. No, that's this. So this is x. On separate drawing, shade in the sets, complement x. That's going to be don't know if I can have a hole in this in Excalibur drawings. So let's find out if I can just make it look roughly right. So that's complement x. Oh, Stian, hello. Good to see you. You weren't joking about the math book yesterday. What I meant about That's You is I watched you on YouTube some time ago. I didn't know that when you popped up in the chat the other day. Nice to meet you again. Yeah, good to meet you. Good to reverse roles. Stian is we raided Stian yesterday. I've been trying to inject a correct pronunciation of your name, Stian, into my brain, but I haven't successfully done it yet. Yeah, indeed. It's all maths here at the moment. There is some code. It's close. It's close. You know what I'm going to do? I'm going to look it up. I'm going to get my pronunciation perfect for next time you drop by. Not to repeat myself too much, but we got a little prankster earlier today, Stian. We got somebody who sent me some code that didn't do what it was alleged to do. Fortunately, I didn't run it. Okay. Yeah, a little prankster. Yeah. But I learned my lesson, not directly. I didn't run the code, but I was reminded of the wisdom of not running code from sources on the internet. Yeah, definitely drop Stian a follow if you like programming, you like aesthetics. Great aesthetic on Stian's channel, I feel. Lagging Codger, thank you for the sub. Yeah, drop a follow to Stan. Stan's a great channel. We had a good time yesterday. And a lot more terminal oriented. I'm going to say very, very terminal oriented. Terminal oriented enough that the web browser seems to be in the terminal as well. Though I may be mistaken about that. Yeah, that is a nightmare. That is a nightmare. Yeah, code that would install a backdoor or something. Yeah, it's just not worth it. All right. Where were we? My brain is really fuzzy today. Okay, so yeah, we're sketching that. We've sketched the complement, and now we're supposed to sketch the intersection of the complement with 0, 2 and 0, 3. I'm going to do this with another box. Okay. 0, 2, x 0, 3. Now that is going to be... Wow, what a terrible intersection. What a awful. Okay. So along the x's, we're going from 0 to 2 and 0 to 3 on the y's, which gives us this blue, if this would highlight properly, which one day I will get my whiteboard working properly. Okay, and then we're intersecting, because it's an N, so it's intersecting. And so our intersection, which is going to be in green, is going to be this L shape, I think. There we go. Okay, and I think we end up with this. How long have you been streaming, Stan? I haven't noticed you pop up before, but you may have been there before without me noticing. Okay. Same deal, only different. We're going to be going from -1 on the x to 3 and 0 to 2 on the y, which is not this. Not very consistent. I see, not too long. But it's cool. Jackness says, hey, Newana, shouldn't the X set be a rectangle? On 3. 1, 3. 1, 2. You're right. My attention to detail today is clearly not there. Thank you for the spot. I appreciate it. And then in theory, this should be this. Assuming I haven't made a... No, that won't be right. It'll be... I'll need to do that one again. Now, what was that? Intersection with 0, 2, 0, 2, 0, 3. That's this. So actually, it's like a little cutout. Unless I've made the same mistake again. Got to double check my work because I'm clearly in one of those moods. Okay. Alright, so 0, 2, 03, rectangle, 1312. Okay, I think that's right. Starcan. So the software that I'm diagramming with is called ExcalaDraw, and you can load it up yourself. There's an alternative called TLDraw. Or rather, the flagship product of TLDraw, which is another whiteboard. Try out both, see which you like. TLDraw is slightly different in that it's backed by a company that makes a whiteboard SDK, which is pretty cool. All right, now where were we? Let's come back to this one. Okay, get my intervals right. -1, 2, 3, 0, 2, 2, on the plane r squared, shade in the sets, complement x. Well, we know what that is. I'm just going to shade this in the same diagram for speed. There's probably a way you can get holes in these shapes, but wow, that looks horrible. Okay, here we go. That's the complement, and then we want to intersect it with -2 to 4. So -2 to 4, and then -2 to 4, and then -1 to 3. Okay. -1 to 3. All right, where were we? Okay, that's what we want to be on. Okay, then we're intersecting this, we're intersecting the complement with this yellow box. No way, it's -2 to -2, okay, -2 to 4, -1 to 3. Okay, great. So we should be intersecting this. So we're going to get like an outline. That should be fun. Aside from the fact I don't have an outline. And let's draw another shape. Okay, let's make this solid. Okay, I think that's what we're looking for. That type of thing. Sebastian is 3 hours away from 1,000 hours streamed. Well, you'll have to get on that. We'll have to get on that. We're all beginners to the world of streaming, really. Do we think streaming will be around in 100 years? What's in the cup? Well, it is an iced coffee. It's an iced, in case you're interested. It is I think it's Peruvian. I think it's a Peruvian bean. AeroPressed long to get my brain woken up, though it hasn't really worked. And then I will say here's a divisive opinion for you. I know we're supposed to not get too controversial here, but it's store-bought ice. I pay the supermarket for ice. I don't make it myself. I don't think I'm competent enough to make ice, honestly. And the ice from the ice you make yourself takes so long. You got to, like, for me, if I have to think, if I want an iced coffee, I want one right now, and I don't want to think 12 hours ago that I need to make ice. That's just, some people are different. And also I feel like the store-bought ice makes it just tastes nice. People think I'm really off for that one. Some people's personalities, if you talk to them about store-bought ice, they lose their minds. It's like AI to them. It's like it's like a moral failing, I think, to some people to buy ice from the shop when you can make it in the freezer. But I just like it better. But I'm also a bit of a cocktail head, so it's handy for cocktails too. Okay, 5. Sketch the set. All right, we've got a weird set here. Just to warn everyone, I know it's been a funny stream today. It's about to get funnier. All right, we've got x squared plus y squared greater than 1, less than or equal to 4. I think that will be a ring of some kind. I think that will, oh gosh, okay. So I think we're going to end up with, like, yeah, I think we're going to end up with like something that goes like this. I think this is what we get. Oh, that's a bit odd. Okay. Yeah, quantum proofing or encryption. I saw that Cloudflare has they've got a new claim that their encryption is host quantum, which is nice marketing. I don't know how they can. Well, I guess to me, quantum computing is still in the realm of like, wow, wild, weird stuff that nobody understands. But maybe it's true. I think I watched. You know what I watched? I watched a great YouTube video about this. I watched a great YouTube video about this. I watched a great series of YouTube videos about this. There's a woman and she's at a desk, maybe. See if you can find this from my description. There's a woman. She's got like an academic vibe, and she's in like an office maybe, or there's a desk or something that indicates that this is like a proper office, not like this. And she's talking about like grids, like lattices. Is that the right term, maybe? And She's not super big, I don't think. Let me see if I can find her. Wow, it's going wild here. What is her name now? It's going to bug me. I'm on the wrong channel. I'm on the wrong channel. Too many channels. Oh, I just can't remember her name. Great videos though. Very like legit. No, not her. It's not Sabine, although she also looks legit. No claims that she's not legit. Gosh, it's going to bug me now. Ah, it's got a terrible, terrible YouTube channel name. Terrible YouTube channel name. Great videos. Great videos. No, like, no weirdness. Less weird even than my videos. And my videos are not that weird. Yet. Chalk Talk. Chalk Talk Maths. Like, what is this? 10 videos? 10 videos. Gold, every single one. And you know, I love 3 Blue 1 Brown, of course. We cannot disrespect 3 Blue 1 Brown, but I did feel like these videos, they were a little closer to, like, I got further into them before I got to the point of, like, you know when you get into a 3 Blue 1 Brown video and you're like, you get to a certain point in the video and you're like, wow, bro, that's crazy. You're telling you, wow. And that's your only reaction after, like, everyone has their own percentage of the video in that they get before you're like, bro, that's wild. Wow. But you're not really following. Anyway, I felt like her videos, the ratio, like the factor of getting through was notably higher. Yeah, really great videos. Definitely check out Chalk Talk Maths videos if you're interested in that type of thing. Yeah, just really legit. The one I was thinking about, lattice-based cryptography, that was the one I was thinking about. Yeah, and I think probably the one to start with is the post-quantum cryptography one. That sounds like probably the right one. Oh, you've already watched them, Kiara. Chiara. Yeah, it's a shame. It's a shame when you watched all the good videos. It's hard. I only recently started watching Folding Ideas. I didn't even watch any Folding Ideas because I didn't like the thumbnails. It's thumbnails for you. But pretty good. Anyway, where was I? Let's try and get this. I'll try and get this because I gotta get on a train. The train is on the way to me right now, and I need to get this done. Okay, so we're on 5. We're on the circle one. We've drawn it based on a bit on a guess that it looks like that. I think it looks like that. I'm reasonably sure it looks like that. And then we're supposed to shade in the set bar X, which is like the opposite. So to do this in Excalidraw, this is the main challenge now. We're just getting into how do we actually use the software. Let's send it back a bit. All right, and then this, we can do that, and then make this white, and then, shade all this down a little bit. And I think this is what we get. I think that's what we get. Yeah, Veronopith, yeah. It's well, this theoretical physics, no. This is reasonably fundamental set theory. I say fundamental like it's basic for set theory. May not be basic to an individual person, but it's beginner set theory. Okay, now number 6. Sketch the set. This looks distressingly short for a final question in the series, doesn't it? Six. Sketch the set x equals coordinates where y is less than x squared on r squared. So y equals x squared would be like, it would be like a parabola. Is that the right word? Parabola. And it would go through 1, 4. Yeah, we go through 1 and 4. So it goes, it looks like, oh my, look, that almost looked good for a moment there. That almost looked good. Look at the first part of that. Wow, that almost, if you just ignored the top half, that almost looked like it was alright. And then I lost it. And then I lost it. Okay, now we're looking for where y is greater than, so we need to shade it in. Let's do a rough job of shading this. Somebody's saying, Jara's saying, I will lose it if K ever says something which I would never say. I would never say that. I would never say that. That's the thing. That's the thing that I should put this in the rules. The rules for this channel are mainly, for me, never to say that phrase. And never to run any untrusted code either. If I ever run any untrusted code, or I ever say that phrase, I'm quitting streaming for life. Because I'm not fit for the game. Okay, I gotta do the opposite. Let's see, Radowid, you're almost trying to get me to say the phrase there, but I won't do it. I will never say that. I have never said it, I will never say it. I don't even think my mouth can produce those shapes. Yeah, the cynic, yeah. You really took one for the team there, running that code. And I'm glad it didn't work. Glad it didn't work. Nobody else ran any untrusted code either. I should say it's a room of see, this looks awful. Look at that. Need to change this. Need to sort this out. Okay. Still looks bad, but slightly less bad. Razvan, just finishing up the stream, just doing some maths. How you doing? Good enough for who it's for, yeah. Okay, 1.6. Answers. Here we go. Let's look at these. All right, what did I do again? I think I did the first group. I'll use my red pen. 0, 2, 5, 8, 10, 0, 2, 5, 8, 10. 0, 1, 2, 3, 7, 9, 10, that's right. Empty set, that's right. All of the numbers, that's right. E, yeah, that's what I said. 4, 6 is right. 5, 8 is right. 5, 8 again is right. And 1, 2, 3, 4, 5, 6, 7. No, 1, 2, 3, 4, 6, 7, 9. So without 5 and 8, that's right. 3. Did I do 3? Yes, I did. Okay. That was right with thanks to the person who pointed out my error earlier, whose name escapes me just this second. And I can't quite find it in chat either, but thank you for that. Okay, so that's right. That's right. That's right. 3 we don't get. 5. Sorry, 4 we don't get. 5 we get. Which I got wrong. Ah, of course I got wrong. Squares. It's squares. It's actually. I was thinking too closely about 4. It's actually this, because it's 4, because we've got the square in there. Okay. Attention to detail problem, but not a set understanding problem. One of the good things about being a software engineer is attention to detail is slightly less catastrophic. Well, let's go cross. Can't mark myself up for that. Okay, and we don't get an answer for 6. Fine. Okay, that's it for today. We've had 2 slightly smaller streams this week. Hope you have actually no, what have I'm finishing up too soon. But I will be finishing up now. Next time, we're going to be looking at Venn diagrams. I was hoping we would look at Venn diagrams the whole time, but we didn't get to it. But I think this will be fun. And then it feels like we're getting pretty, yeah, index sets I don't know about. This looks horrendous. Let's just skip all that. Let's just skip this. Whatever this is. Whatever that is, nobody needs to know things like that. No, we will do that. And then number systems, and then Russell's paradox, and then logic. Logic's going to be good. I'm excited for that. So we just got to smash through this. I skipped some exercises today. You'll be very proud of me. I didn't do all the exercises. I realized I was being a scrub about the exercises. I just wanted to do them all. I wanted to be a good student, but ultimately life is not about being a good student. So I skipped some, and we're going to keep working like that. I also made a few mistakes. Is that related to skipping them? Probably not. Probably just mental tiredness. Yeah. Okay. Half marks. Thank you. Thank you, Chiara. Thanks, it's really Ren. Enjoy the rest of your day too. Veronipith says this was kind of zen. Nice. Glad. That funny looking shape was a sheaf. Yeah, glad you put Bastian. I will see you soon, hopefully. And thanks for all your streams as well. Now it is time for me to figure out who we're raiding today. This is my favorite part. Which of these magic symbols means raid? Okay, great. Now, let's see. Let's see what's going on. AI streams, vibe coding streams. You can find that. I'm sure people enjoy those. Somebody's making music. That's interesting. Game dev, game dev, game dev. Yeah, it's pretty early, isn't it? It's pretty early. Oh, right. I think we got. No, wait. It's a bit big. Some people just stream them looking through the streams. I'm not doing that. Maybe I'll start doing that. Hey, why not? Let's check out some lists. Why not? I mean, it's let's do it. Let's do it. Let's do it. Let's do it. We can do it. Okay, we're checking out Janet A. Carr today. Hope you have a good rest of the day. I'm going to see you next week. I'm going to see you probably Thursday, definitely Thursday, maybe before next week. And have a good rest of your weeks, everyone. Somebody said that was threatening. Hopefully that's less threatening. And thanks for hanging out. Let's raid.